Hello everyone. I hope is everyone great. In today's video, I am going to show you how to build a dimmer circuit with the Arduino. A dimmer circuit can be found in houses and hotels, and it uses a potentiometer to control the brightness of one or more bulbs. In our circuit, we are going to control the brightness of an LED as example. To do that, we are going to use the analog input of the Arduino and the PWM output. On this video, I am going to show you all the details of the programming and the assembly of the circuit. And I am also going to show you a way to monitor the parameters of our code by using the serial monitor. So, let's go to the video. Okay, firstly, I'm going to quickly explain about the analog input of the Arduino board. The analog inputs are located here at the bottom, and we have a total of 6 inputs. These inputs have a converter that we call ADC, which means analog to digital converter. This converter will be responsible for transforming our analog signal into a digital value that will be used by our programming. This conversion depends on the resolution of the ADC converter of each Arduino model. The Arduino Uno has a 10-bit ADC converter, which means that the analog input signal that varies between 0 and 5 volts will be converted internally to a value between 0 and 1023. Which means that if the analog input has 0 volts on it, the Arduino will convert this voltage internally to a digital value 0. And if the analog input has 5 volts on it, the Arduino will convert it to a digital value of 1023. Any value between 0 and 5 volts on the analog input will be converted to a value between 0 and 1023. As an example, let's consider that we have 3 volts on the analog input. To find the converted value, we just need to apply the rule of 3. In the rule of 3, 5 volts corresponds to 1023. Then, 3 volts will correspond to the value that I want to find. Let's call it X. Let's make the cross multiplication. And we get the following equation. The converted value, X, equals to 1023 times 3 divided by 5. Which is going to result on the 614 value. This means that 3 volts on the analog input will be converted into the value of 614. Now that we understood how the analog input works, let's go to our circuit. Okay, here in our circuit, we already have on the breadboard our LED. And on the cathode of the LED, we already have our resistor. I've also made the connections of the ground and the 5 volts that comes from the Arduino board. The left terminal of the resistor is going to be connected on the ground. And the anode of the LED is going to be connected on the PWM output, which is on pin number 3. And now, we just need to grab our potentiometer, which is going to be connected on our analog input. We are going to connect its right pin on 5 volts. Let's leave the wire color in red. And the left pin, we are going to connect on the ground with color black. And the middle pin, which is from where our analog signal is going to come from, we are going to connect it here. The potentiometer is a variable resistor that varies its resistance when I rotate its cursor. This will make the analog signal to vary from 0 to 5 volts. And this signal will be used to control the LED brightness. So, let's start the programming of our code. Here in our code, we're going to start by defining which pins will have connections. Let's use the command define to name the LED pin, which is pin number 3. And we're also going to create an integer variable called analog that is going to store the value converted on the analog input, which is the signal that comes from the potentiometer. This signal is going to be used to control the duty cycle of the PWM pulse that controls the LED brightness. If you are not familiar with the PWM modulation, check out the video we've made about it on the card that appears on the top of the screen. Now, in the void setup function, we are going to define, by using the pin mode command, that the pin LED is an output. Once this is done, we can go to our void loop function. To read the input signal that is on the analog input, we're going to use the analog read command. And we're going to store the input signal value in the variable analog that we've created. The analog read function has only one parameter, which is the name of the pins printed on the Arduino board. So, considering the connections on our circuit, we're going to use the input A0. Now, what is going to be the programming logic of our code? We want to control the LED brightness by using the analog signal as a reference. In this way, if I have 5 volts on my analog input, I want to have the maximum brightness on the LED. On the other hand, when I have 0 volts on the analog input, I want to turn off the LED. And any other value between 0 and 5 volts on my analog input will make the LED to have a different brightness intensity. To make this happen, we're going to use the command analog write, which is the command that controls the PWM modulation. This command has 2 parameters. One is the PWM pin, and the other is the value of the duty cycle that should vary from 0 to 255. If I put the variable analog here, it will not work properly because the analog variable is varying from 0 to 1023. To convert the analog range from 0 to 1023 to a range between 0 and 255, we can just divide the analog read result by 4. By doing that, when my analog input has 5 volts on it, the analog read function will return a value of 1023, which divided by 4 is going to result in 255. This value is then applied on the analog write function, making the LED to stay at its maximum brightness. Let's start the simulation to see what happens. Let's close the code tab and then start the simulation. Firstly, notice that the LED is off. I am going to increase a little the voltage on the analog input by using the potentiometer. By doing that, we can see that the LED brightness increased. And it increases even more as long as we rotate the potentiometer's dial. One thing we can do to analyze our circuit is to monitor the voltage on the analog input. We're going to do that by selecting a multimeter. The negative terminal of the multimeter is connected on the ground terminal with black color. And the positive terminal I'm going to connect on the analog input. Now we can monitor the voltage applied on the input. Let's start the simulation again. And we can see that the potentiometer is sending 5 volts on the analog input and the LED has maximum brightness. And as long as we reduce the voltage applied, the LED brightness is proportionally reduced. There is also a way to monitor the analog input signal through the code. To do that, we're going to use the serial communication. Let's first stop the simulation. The first thing we need to do to configure the serial communication is to define the communication rate, which in our case is going to be done by using the serial begin command in the void setup function. In the void loop function, we're going to monitor the variable analog, which should vary from 0 to 255. To do that, we're going to use the command print so that we can see its value in the monitor window. When I start the simulation again, the command print will print on the serial monitor here the value of the variable analog. Which means that the 500 mV is converted into the value 25, which is the value returned by the analog read command divided by 4. If we increase the input voltage, let's keep it in 5 volts for example. We're going to have in the analog variable the value 255, which corresponds to the value 1023 divided by 4. By doing that, we can monitor any variable in our code. This can be very helpful during the code development. And that is it. We could see in this video how we can create a dimmable LED by using just a few components. I hope you have enjoyed. See you in the next video.